to Disambiguation. I'm your host, Michael Fawcett. Each week we interview experts in AI, generative AI, and business automation to help business leaders understand how to use these tools for the biggest business impact. In our show today, we look at AgTech, farming in the age of AI and IoT. I'm joined by Bill Britton, Vice President of Information Technology, CIO, Cal Poly Information Technology Services. Bill, welcome.
Thank you very much. It's a real pleasure to be here, and I'm really excited to talk about some of the things that we're doing at our Polytechnic.
You know, I when you and I talked about this a little bit before, I get really excited too because I haven't done anything around, agricultural technology in quite a while, and frankly, I know there's a lot of motion, a lot of things that need to be done there. So I think it'll be really interesting for the audience to dig into this a bit. Before we get into the topics, though, can you just give me a quick introduction and a little bit about your experience with the Digital Transformation Hub and kind of how AgTech, AI, how that kind of falls together with that Digital Transformation Hub?
Sure. Well, as I start off with, it's a Polytechnic, and so we really serve and satisfy 6 different colleges at the university with some very varied support structures, and ag being one of those. But we also have a very high-end engineering, College of Engineering, business school, architecture, and liberal arts programs, all very varying, and a College of Math and Science, all very varying in what their requirements are. And so one of the things that we tried to do was when I first arrived at the university is we looked at the foundational enterprise of the university and found that we had a significant technical debt. And one of the ways that we looked to solve that technical debt was to move all into the cloud. And so we chose AWS as our cloud provider, and we went all in. And at that time, one of the things that we started talking to them about is this experiential opportunity for students, not just to do their homework and store it in the cloud or access
Right.
classrooms in the cloud, but really understand what is cloud all about and how do they use it in their experience and how do they use it and interact with others to understand what cloud does. So it creates this cloud knowledge base. And AWS and ourselves came up with the concept of what they call a cloud innovation center. We call it digital transformation. And it's a partnership between them and us. And we have AWS employees on staff. I have staff that serve in this DX hub to really expedite the conversation. AWS allows us to educate students around the area of working backwards, which is their innovation concept. And so we really build a 10-week platform around knowledge build on cloud capabilities around public sector problem sets. One of the ones we originally looked at was what to do about all these electric scooters on sidewalks. And so it became a really interesting problem set that, here are all these people riding on the sidewalk instead of in the street where they're supposed to be. And how do you stop them? Our DX Hub experience looked at the problem, worked backwards from, well, if we could get them off the streets. And basically, our student staff built a Raspberry Pi that had integrated into it a GPS as well as a meter that measured the cracks in the sidewalk. And so every 6 foot is a crack in a sidewalk on the street. So if the GPS says you're near a sidewalk and the meter is going off every 6 feet, the motor turns off on the scooter. Now, this is a no-brainer, right? This is something that students accelerated thinking about. But utilizing data, utilizing the cloud, utilizing big data, working backwards, they were able to develop a $2.50 solution to the problem.
Yeah, that's really cool, and it's so good to hear an experiential learning path around some of these technologies because I mean, frankly, they're going to have to deal with all of these different concepts when they move into the workforce, no matter what job direction they take, right?
Absolutely, and that's our whole context. Is we think there's 3 different learning methodologies at the university, and that's the classical academic methodology, which everybody does really well at that. The secondary then is clubs. The third is in the research areas. There's really the extended beyond the clubs and the research is internships. And what we like to think is we're kind of that in between the research and the internships. in that we bring the practical experience instead of in an internship offsite, it's to them on campus via this DX Hub experience where they're the project lead, they're this chief engineer, they're the marketing communications team, and they work all these problem sets collectively. So it might be an engineer and three students from liberal arts and two from math and science. So it's a team element developing that solution set.
Yeah, that's cool. So how does AgTech get into the radar here for Digital Transformation Hub? How did you guys get
So
into this project?
interestingly enough, one of the offshoots of our cloud experience is really the massive amounts of data that is being generated around campus. And then we start to look at things like AI. And again, it's just adding more volume to the data being pushed around campus. And so, one of the things that we did, which was kind of a no brainer, is we did a day in the life of the university networking. And we picked a Sunday because we thought it would be a relatively benign day, not a lot of homework going on, a little bit of free time and that sort of thing. And we went down to the device level to figure out what was going on. And in that, we found a student who was using their Xbox as a geospatial server for a game with 1,500 people on our network. And that
Ouch.
student in a 12-hour, yeah, 1,500 people on our network. In that 12-hour window, that student pushed 1.7 terabytes of data over the network. Again, geospatial, just the imagery server
Yeah.
of the competition.
Yep.
And so our concern was, with all this data being generated, what happens if that student decides to hold that same competition on the day we're registering for classes,
Mm.
where everybody wants to be registered within the first half hour? And so they're all lining up to log in. And then we can see the little meter on the internet go, all the way to stop and tilt,
Yeah, yeah.
and we don't get anybody registered. So we started looking at how do we create different lanes of traffic now that are in a more modern context
Mm.
than traffic management and shaping of the past. And what we started upon was the area of 5G. And we
Mm.
started looking at the different utilizations of what a private 5G can do for us. And we created a 5G lab. That 5G lab is actually built right next to our strawberry fields. And one day, we're standing there in the parking lot looking at our wonderful signal coming off the hill. And this robot goes past us into the strawberry field. And it's literally a strawberry picker. It is a robotic machine that goes out in the field, takes a picture of a strawberry, evaluates the strawberry, and then uses a laser cutter to cut it. And my question was to them, hey, what are you using to control that? And what about all that data that it generates? And they said, oh,
Mm.
we have terrible connectivity. And my ears just perked up. And I thought, wow, wait a minute, terrible connectivity. We've got this 5G lab. What if? And then we started interviewing and talking to people about what's going on in the field as far as ag tech goes. And one of the things
Mm.
we found out that one of the long poles is the connectivity to the field, particularly more so in a
Mm.
mobility standpoint. How do I get the mobility communications networking into the field? Because when you start talking about things like edge computing and other things, if they
Mhm.
can't connect to the field, there's no edge compute
Yeah.
to worry about.
Yep.
And so what we found was some very basic disconnects, and that if we could accelerate the communications to the field, i.e., via a private 5G network, that enhances the opportunity for not just connectivity, but AI and AI inclusion and edge computing and all sorts
Mm.
of new data philosophies on how to bring data back and forth from the field. So a little bit of discussion with our strawberry people, and they got excited. And the next thing we know, we're getting calls from all sorts of people going, understand you have a fix for our problem. And we haven't fixed it yet. We're evaluating what does it look like.
Yeah. Yeah, well, it's a problem I've heard before, and I know, a lot of the agriculture industry, they've gone to connected tractors and all these sensors and different, things for, Internet of Things type data sensors to look at moisture and heat and
Yep,
all those different things, right? So,
right,
I mean, that's a huge, I would assume connectivity, you're not in the greatest of locations to begin with for connectivity. So,
right.
it must be a serious challenge for
Yeah, but
actually being able to
rural
use them.
America is not lit up, right? And
Mhm.
that's the problem that you see. And so we're looking at all sorts of different options. That's what's nice about doing it in the
Mm.
context of a laboratory environment. And geographically, the university is very well situated. We're in the middle of numerous mountain ranges, and then we have
Mm.
the coastline. So we have everything that goes on in the real world.
Yeah.
We also build really good buildings that are from phenomenal RF non-attenuators where they really block every signal. So we can prove that
Mm.
it's hard to push a signal from point A to point B. And that's really what we're trying to look at is things like neutral host, all sorts of unusual techniques that then get carried
Mm.
out into the ag field.
Interesting. So, talk a little bit more about how some of these specific technologies, like AI, like Internet of Things, 5G, how do those kind of come together, and how are they integrated into your ag tech project?
Yep. So that's where the laboratory really comes into experience. And this whole working backwards that we've adapted
Mm.
from AWS has been a significant upper for us to do this. What it's allowed us to do is to really say, what is the problem we are trying to solve? And
Mm.
then work backwards with all the facets and tenets that are necessary to evaluate the performance. One of the biggest ones that we were working on right up front. So we've actually set up four different lab nodes for this 5G private network. And one of the ones we worked on was a pier situation where we have Cal Poly has a pier. It's about a mile and a half offshore. It goes and then it ends. And we did an evaluation. What would it cost us to run fiber out there? Because we currently run a T1 out there. And for those who don't
Mm.
remember, T1 is 3 meg.
Yeah.
Try to do email with a 3 meg connection nowadays, and it just doesn't work. And so what we priced out was how much would it cost us to run fiber out there, and it
Mm.
literally was in the millions of dollars because of the road construction, strapping fiber on a pier, a steel pier, all the way. I mean, just really price point.
Mm.
So one of the things we did was we did a 5G private network fiber replacement evaluation where we are using a signal that we shoot from the start of the pier out to the end of the pier. And we're able to send 300 megs on this signal out to the pier. And once it gets to the pier, we're able to do signal slicing or bandwidth slicing, which
Mm.
means there's a general reception for that signal, as well as we're running our eduroam across that signal. So we're
Mm.
able to slice out and utilize specific bandwidth portions for specific Cal Poly utilization. So it's
Mm.
really a game changer for us, and we're looking at how far can that go, and all the maritime climatology issues associated with that. The key is again experimenting these things, and so the same thing applies for in a field where there is
Mm.
numerous length and connection points, climatology, cloud, geographic. All those things are part of the how do I get a signal into the
Mm.
middle of it. The other thing is how many different receptors, sensors, signal data points
Mm.
do we have? One of the things that we see is there's a ton of development. Pardon me. I'm allergic to sensors. There's a ton of data, new starts, companies, innovation going on in ag tech, but they're really all kind of in individual silos. And what they see is they create a machine language for a sensor or a capability that goes to a dashboard, and that the person that's going to put all this together has to take all these multiple dashboards and figure out how to.
Mm.
So one of the things that we're looking at is if I can now get all of this information, and oh, by the way, I'm going to apply some edge computing so that now instead of
Mm.
having to do all the compute at the receive end, part of it can be done in the field on the device
Yep.
itself. How do I send all that across? How do I get it really to talk the same language? So remember, each of these sensors, each of these
Mm.
watering devices, each of these tractors are all talking their own machine language. What
Yep.
if we were able to teach them a singular language, which then makes them available to be displayed and analyzed on a singular dashboard? That, oh, by the way, that what's teaching them that language is an AI product that also then
Mm.
allows you to control those with that singular AI device. So that instead of the farmer of the future having to monitor a million dashboards, they're monitoring a single element that they've made sure they
Mm.
supply all the information to.
Mm.
And what we're looking at then is this, and we haven't done, but I mean, where could this go? Where this could go is that then think in that generative context that if the farmer says, I've got a crop that's in the lower 40 that's not doing as well as it should, with all that sensor data, all that information, climatology, fertilizer, seed, everything, you could use a generative AI tool to say, what product can I produce that will yield a higher yield
Mm.
in that? And what are the techniques I need to plant, grow, and pull it out of the ground? And all of that is a generative AI support structure for that farm.
So, I mean, you literally, it's just like we talk about virtual assistants in business. This is the same
Right.
for the farmer. It's a way both to get access to a bot that can help them brainstorm around
Yep.
different problems,
Right.
and
And that,
then
and that again,
also
that's
manage.
where
Yeah,
we're headed. So
yeah,
it's a really interesting place to
that is
head,
interesting.
because again, what we're talking about is the number of fields, the amount of water, all of those things are at high risk. The reduction of
Mm.
the soil availability, the reduction
Right.
of the right nutrients, the climatology issues, all of those are ever changing now. And so that farmer has
Mm.
to be a predictor. Oh, no, wait a minute. I just said predictor. Generative AI does prediction.
Yeah.
These things are being married together in a context they've not been thought of before,
Mm.
which allows that farmer a ton more options. Now, so in that, what we're also talking about is democratization of that data of that field. So
Mm.
if we look at the current way that ag tech is being evaluated and being developed, that information goes to the builder of that tool, i.e., a tractor. So
Right.
that tractor manufacturer owns that data and they resell that information to others, not
Mhm.
to the farmer. So the key becomes here,
Right.
how much more control can that farmer, through the democratization of that data, have over their own farm instance?
Mm.
And so this is using those same principles that we talk about in AI in, as you said, the commercial world in that farm instance. And so we're really hoping that this just picks up and explodes, and we're already seeing it in the interest level
Mm.
behind the kinds of things that we're talking about validating. Again, we're not
Mm.
mass producing, we're in the process of validating, testing, writing
Right.
papers, writing evaluations so that others can gain from that knowledge base.
Yeah. I mean, it seems to me that that this whole concept, the idea of getting all of the data sensor and machinery in a way that can, talk on the same channel, basically the same language, and then have the ability to bring that together and manage all of this in a single package, basically. That should apply to a lot of things, I would imagine, right? I
Absolutely.
mean, you got things like oil platforms or
Yes.
drilling or coal. I mean, any of these kind of activities that are distributed with heavy opportunity to collect data and take action with that data. I mean, the same kind of solution could work across a lot of different
Yeah,
things.
we're seeing that already in other
Mm.
areas, and they're more advanced in these areas. And what we're seeing, the biggest thing, that the biggest eye opener I had, is we interviewed some farmers, and we asked them about their cell phone, and we said, does this help you in the field? And they go, I don't even take it. I don't have connectivity. Why would I take it? And
Mm.
so, if you think about this for a minute, so we know that this new modern phone has the same compute capability that put men on the moon,
Yeah.
and we're not utilizing it in that ag environment because of lack of connectivity. So that connectivity issue with edge compute and other, that opens up a whole new world. And again, it's how do you make
Mm.
it so that it's mobile, and how do you make it so that it's useful and cost effective? And
Yeah.
so, one of the things that we're hearing is people saying, oh, we'll just hook up Starlink to the field. And that's certainly an option, but does that give them the breadth of the sensors, cape that interact, so all these connectivity. So it may be the node that you hook up to, but then how do you make it mobile from there? Which is
Mm.
where this concept of adding the private 5G
Yeah.
network to make it that mobile connected across the field.
Right.
The other thing that we're looking at in this, which is kind of a mind-boggling thing, but that same connected connectivity is a major issue in human safety issues in the field.
Mm.
So if you think about it today, with no connectivity in the field, somebody gets hurt, they literally put them in the back of a truck or on the tractor, drag
Mm.
them back to where you can get a signal and call an ambulance.
Hmm. Yeah,
So
that's crazy. So I mean, you completely change the dynamic there if they have the availability in the field.
right,
That's amazing.
absolutely right. You can
Yeah.
absolutely change that. Now, again, that human safety factor is also a measurable that you want to have in
Mhm.
things in the field. And I mean, so there are so many new data points that when you start to think about it, again, the beautiful part of being a polytechnic, we have a ton of demands for data for ag. We
Mhm.
have chickens on campus who wear Fitbits, and that chicken wearing the Fitbit, they monitor that for the chicken activity. And when they want that chicken to roost, to lay an egg, they
Mhm.
reduce the size of the hen house, and it shrinks down and the chicken calms down and they lay an egg. And when they want that chicken to eat more, to produce more and exercise, they expand that hen house. This is all done over the internet. Now,
Interesting.
that internet, that data gets thrown on the Wi-Fi and now becomes a competitive element with all
Mhm.
the other student data and other university data. And so we're running out of room to have all this information
Right.
on the network.
Yeah.
And then how do you prioritize all of these things? And so again, we're looking at edge computing, cloud based networking to help solve these problems so that as you build out your collection requirements, your network is expandable as well.
Hmm. I mean, that that like I said, that has a lot of application, it seems like, across a bunch of different ideas, but the beauty of being able to use a private 5G network is, that has to open up all sorts of opportunities for farmers, so
Absolutely.
that's amazing.
We actually refer to it when we're trying to explain what we're doing. We say we've created an HOV lane in our network,
Mhm.
high occupancy vehicle, where we know who's on it, we know what speed, we know what kind of bandwidth, we know the temporal aspect of how they're going to use it as they transcend that HOV lane. So we may only allow them 10 seconds every hour. That gives us another 50 seconds or 50 minutes and 50 seconds in that hour for other data to go across. So
Mm.
being able to manage to that level is a game changer for
Yeah.
CIOs to be able to make sure we get all the data where we need it to go when we need it to go there.
Mm. I mean, you're essentially multiplexing the signal so that you can manage that bandwidth across all the different applications.
Absolutely.
That's interesting. So, what are some of the real world benefits? I mean, you mentioned the idea of the behavioral modification of the chicken. I guess that's a way to think
Yeah.
of it anyway, and
Yeah.
that's amazing actually. But what are
Yep.
some of the other kind of benefits that you think will come from this project, both for the university, but also just for the agricultural community
Yeah.
at
One of,
large?
one of the big ones we're really interested in is things like watering. So,
Mm.
um, water in the state of California is definitely a high risk challenge area.
Yeah.
So the right kinds of watering with the right kind of sensors is massive cost savings, massive risk reduction. And
Mm.
so we're looking at those elements as being tied together, dew points in the morning, dew point at night. I mean, all these different factors and how they could be weighed out, and making that part of the whole decision process, not just a singular streamline. So again, we look at watering as an effective area.
Mm.
One of the things we're talking about is fertilizer, and not just fertilizer in the field, but fertilizer as it impacts the population nearby. I mean, all sorts of air sensors and other things that could be monitored and managed. So, what we're really trying to do is create an ecosystem around that farming system
Mhm.
that is measured and evaluated to improve production, to improve usage, to decrease risk for others in the area. I think
Yeah.
that there's a whole new way to look at how you can support and sustain farming with
Mm.
with this capability.
I mean, it's to me, it seems so much like what conversations I'm having with business leaders right now around decisioning, right? How do I make the best decisions in my business? The same thing's true here, and yet in this business, they've not really had that much data or access to the data, I should
That's,
say, to be able to support that decision process.
yeah, that's what we're seeing. This is that there are large agribusinesses who have spent millions, billions of dollars on research and development.
Mm,
The question is, how is it being spread out? And again, it's back to that democratization question that
yeah.
I phrased, which is really how much does the farmer get where they're making the decision, or they have a tool to help them make that decision. Again, today, if you think about it, we're still using the Farmer's Almanac. Nothing wrong with all of these things. We're using the
Right.
farmer's knowledge. It's that's person's land. It's their
Mm,
ownership. They've been working it for years.
mm,
But again, climate's changing, soil's changing, even the weather is changing. How
right.
how does all of that play in your knowledge base? Are you at higher risk as a result? And so
Yeah.
again, utilizing predictive tools, sensors, capabilities,
Yeah.
maybe this becomes a more manageable conversation.
Right.
Everything we've read said that the amount of land dedicated to ag is reducing, so that
Yeah.
increases the need. Everything we read says we've got to look at new ways to develop agriculture, hothouse, other things.
Mm,
Again, that all requires differing sensors and capabilities that if we don't tie together and have a way to understand it and parse it quickly,
mm.
then we're kind of dooming ourselves to what happens at the end of the year when we go to collect the crop.
Yeah. I mean, it it is moving this more into to a data-driven model, and at the same time giving that farmer the collective data to actually manage that whole operation much more effectively. I mean, just like, again, the same conversation I have with business leaders all the time, right? It's, you have the data, how do you make that data
That's
actionable? In their case, they didn't really even have a way to connect the data. So
that's right.
interesting. Yeah.
Yep. We see things like, a lot of businesses have already done some smart farming. The
Mhm.
milking machines has gone to a whole new level.
Mm.
The question begins to be asked, and now that you're collecting all that data in that context, how far back do you go to collect data that becomes important to your decision process? So
Mhm.
it's a more of a temporal here and now solution set. What if we could expand it to 365? I mean, it's
Right.
every day of the week. The data is being analyzed and analysis being done. You have now a better ability to really manage your production line.
Right. Well, and you you build out ML models underneath that, and you, over time, that data gives moves into the area of predictive
Right.
activities, so that you can actually make informed decisions based on historical data points,
Absolutely.
and head things off before they happen. Really, that's
Yeah, the interesting one that we talk about is you have to have this concept of what it is you think the end state looks like, and in that we talk about the farmer who's had a tough time over the last 5 years, who says, "Okay, I'm going to take all this data, I want to analyze this data, and ask the cognitive
mm,
AI system. I want to have a crop that yields an 85% yield. I want to be, a market leader in this, and I want to go to market with a high price point." Using cognitive AI, you can evaluate what is the seed you need to buy, what's the crop, what's the
mhm,
timelines on this, can you grow it in this soil? All those things can be evaluated to where the farmer's now making more of a managed decision on what crops they grow
right.
based on market needs.
Yeah, and I mean, we also know, like you said, the total area used for farming is continually being reduced. So
Right.
the only way to increase yield beyond a certain point is with that data, and with the data driven approach.
Yeah. I'm afraid that we're going to have to do these kinds of things for the future.
Mm,
Transitioning areas that have uh, failed,
mm,
can they be transitioned back? What can we do to revive those fields? Those kinds of
right.
questions we can begin to address now with the cognitive side of the equation.
Right, right, and I mean, this takes that to a new level of rotating crops and really making sure you keep that land optimized for whatever
Right.
production you want to do.
Absolutely right.
So are there other challenges that we haven't talked about? I mean, obviously, connectivity was one of the biggest things to overcome here, but are there other things that you faced as you
Yeah.
were going through this project, that could help make this a much more practical solution for ag?
There is definitely the human factor. That is the
Mm.
trust associated with, do I trust these sensors and tools? I've been doing it this way for years. My grandfather did it this way. This I don't need no stinking phone to tell me how to run my field. So again, I think there's all of those things that need to be overcome. As I said,
Sure.
when we interviewed several farmers, their comment was, "I don't even take my phone to the field; it doesn't work." So
Right.
some very basic issues
Yeah.
that are associated with it.
Some real change
Trust.
management issues just up front. I mean, that's
You
yeah,
know, you said it. It's the same thing we see in the workplace, right?
yeah,
In the commercial world, is that, do I trust the data? You know, there's a bias in these tool sets. Do I
mm,
trust AI already? Is it going to turn into Skynet where it destroys everything by accident? You know, all those things need trust and evaluation, verification. Again, our context is that's why we want to do it as a laboratory experiment. That's why we're evaluating it as we go. But we see the need for data. I mean, on feeding cows, there's over 170 data points they want measured going across the
wow,
Wi-Fi. As a CIO, I have a mental breakdown. 24/7. You want all this information. You want to
mm,
open architecture on the Wi-Fi feeding this information. Can I parse it down to every 10 seconds? I mean, what
mm,
things can we do that this Wi-Fi is going to have to be this magical thing? And I've heard all sorts of assessments on like AI and the power generation to support the supercomputers, the data pipes
right,
necessary to push all that data. It's growing exponentially. What
mm,
happens when we do open it up to the ag world and everybody else, where
mm,
they're able to use that with their data elements, and they don't want a power station on their farm. They don't want a
right,
data center on their farm. So we've got to make this edge capable and all these other things. To
mm,
do that, you've got to have the networking capable to do that. So really, it
right,
becomes a big shift in how telecoms and others work and think with the rural communities.
right. I mean, you you mentioned AWS, and obviously, great partner for working through this. And it sounds like just applying their methodology, which I love the idea of, look at the problem and work backwards instead of look at the solution and work towards a problem.
Right.
That always seemed a little crazy. But are there other industry partners or stakeholders that you guys have been involved with that you
Yeah,
think
absolutely. So the
are
the
important to the
the
project?
market at large is relatively interesting. So again, the telecoms, the fiber companies,
Mm,
there is the concept in the U.S. today to put a fiber link to every home.
yeah.
How are you going to run it to the middle of a 700-acre farm?
No idea.
And the cost associated with that was going to be exponential. And then once you run fiber to that element, who's the CIO, who's the CISO, who's the network engineer, who's
Right,
the support staff, who's the help desk that helps
right,
you manage and run all of that? We
right.
have to simplify those architectures. We have to simplify that delivery
Mm,
methodology to it. So finding a way to make it more like the use of the common phone, it is
right.
really an important element in all of these things.
Mm,
So telecom is an important partner. Federated Wireless is who we're doing our private networking,
mm,
private 5G networking through.
mm,
AWS, it's about data, right? I mean,
yeah,
that's their specialty. There's all sorts of other new startups in the ag business that are going down these
mm,
areas and doing elements of AI and other things. We're talking to people from Silicon Valley on their AI work that they've done, not
mm,
just about the tech itself being the analysis tool, but teaching
mm,
the AI to individuals. We've got to make this as simple as possible to utilize. And
mm,
so just assuming that I put an AI device in somebody, they're going to be able to use it is not a good assumption. So
right.
really it's kind of shifting the community as they're looking at AI to the commercial, more of the business world, to some of the non-traditional elements that can now use AI.
Right. Well, and it it seems like it's also back to that same kind of approach that we've talked about for years of simplify, simplify, simplify up front and move the complexity behind the scenes so that it can be handled by the appropriate technology, but don't expect the farmer to be the CIO and the CISO and all the other sort of C's that they might need. So you've
Absolutely.
got to simplify for them and make it functional so that they can actually see the true value in it
Sure,
and want to
and build
invest.
those protocols into their app or whatever it is that they're utilizing, so that
Mm,
there's a trusted value built into. Let's say they're using a cognitive AI, Farmer.ai. Boy, I hate to do that, but I did it. Um, and in that is a security
mm,
protocol. There is a privacy protocol. All those things
right.
that they need to do to protect themselves, because they have to ensure to DHS and others that they're protecting their crops and
Mhm.
their value.
Yeah, I mean, that's the thing we didn't really talk that much about, but it is an interesting. sort of different security risks that you might not think about at first, but certainly all of that agriculture is very critical to the nation's security, any nation's security,
Right.
and needs to have a very high level of control around access to that data and frankly control of the machinery too. I mean that
Right.
it could easily be sabotaged. Hmm.
Well, we're also looking then,
Interesting.
in parallel to that, what we've seen is that when you have a high security posture for different data,
Mm,
you also have a very attributable posture. In other words,
mm,
you can track your information. And what we see that
mm,
in agriculture, there are so many regulations on how you grow and what you grow and
right.
what fertilizer you need, that this AI capability aids and enables what looks to be a major mess in regulation and deregulation
Mhm.
of how do I grow my crops and deliver them to prove to you that they're safe and valid to use.
Sure. Yeah, that makes sense. Well, I mean, really exciting conversation, and I could definitely keep going. I think this is a very novel application of several different technologies that come together to do something really powerful. Unfortunately, we're running out of time, but before I let you go, there's one question I always like to ask at the end to just to help the audience. Could you recommend somebody, a thought leader, an author, mentor, somebody that you think is influential that could help the audience in some part of their relationship with technology?
Yeah, I love this question because one of my favorite people to read about and evaluate how they did business was Kelly Johnson, who is really the father of skunkworks.
Mm,
And if you really think about the things they designed, the U2, the SR-71, and other platforms,
right.
they broke all the rules. They literally broke all the rules, but
Mm,
they did so purposely. And
right.
and then they evaluated. So it was really this: break the rules, figure out how to make it happen. Don't take no for an answer. Press ahead.
Mm,
And the way they did it, you just the structure. Like there's Kelly Johnson's 14 rules on the skunk works, and it's really interesting because it says things like small working groups are better than having everybody on the planet know what you're doing. Figure out the solution and then
mm,
tell those other people. It's things like that. So I always
mm,
thought, man,
right.
for this guy to have done the things he did, wow, how powerful. And
Yeah.
I think that's really helped me in how I approach technology. I am never satisfied with technology. I always want to break it and see what more it can do.
Yep. No, I completely agree. And that's a great recommendation. Thanks so much. And Bill, thank you so much for joining today. Really interesting conversation.
Thank you. It went by quickly.
And that's the show for this week. Thank you all for joining. Remember to hit that subscribe button. And for more on AI and other software research reports and posts, check out the arionresearch.com/blog and /research reports. And don't forget to join us next week. I'm Michael Fawcett, and this is the Disambiguation Podcast.